Measure HVAC airflow quickly and accurately using the Temp-Rise formula to convert degrees into cubic feet per minute, and know exactly how to set the system for comfort. The Temp-Rise method calculates airflow by dividing the sensible heat output of the furnace by the product of specific heat of air and the measured temperature rise across the heat exchanger. Start by confirming the furnace-rated output in British thermal units per hour from the data plate, subtracting any derates for venting or installation conditions to get the actual sensible heat available. Then measure supply and return dry bulb temperatures at duct locations that represent system averages, COC. Hold the probe steady until readings stabilize to avoid transient errors. Use the multiplier for air-specific heat of 1.05 British thermal units per pound degree Fahrenheit and the standard air density of 68 pounds per cubic foot at sea level. Then compute CFM as sensible heat divided by the product of specific heat, density, and temperature rise expressed in degrees Fahrenheit. For practical use, many techs use the simplified constant of 1200 when units are British thermal units per hour and degrees Fahrenheit. So CFM equals sensible BTU per hour divided by the product of 1200 and the measured temperature rise. When measuring, ensure ducts are full of mixed air. Measure return air at least 3 duct diameters upstream of filters or obstructions, and supply at least 3 diameters downstream of bends or takeoffs to avoid skewed readings. Account for fan-off, heat soak, and combustion influence by recording multiple readings after steady state for a minimum of 5 minutes and averaging them. Correct for high altitude by adjusting air density if you are above 1,500 feet elevation. Use handheld calculators or phone apps that accept data plate inputs so you do not have to memorize constants. But always carry a backup paper worksheet and pencil for verification and job record keeping. One of the top mistakes is poor temperature probe placement, causing inaccurate CFM and temperature rise readings. Fix it by mounting probes with spring clips inside the center third of the duct and averaging 3 cross-sectional points. Second common issue is using nameplate BTU without accounting for derates or installation losses, leading to overestimated airflow and time. Fix by reviewing the furnace installation manual and applying the correct derate factors or measuring input and output power where applicable. Third frequent problem is ignoring altitude and air density variations, which skews conversions from temperature rise to CFM. Fix by adjusting the density constant from 68 pounds per cubic foot to a corrected value using local altitude tables or quick density calculators before finalizing airflow numbers. BigHomeProjects.com lists qualified HVAC pros and local contractors who perform accurate temperature rise and airflow testing and helps homeowners compare verified profiles and reviews. The directory also helps contractors get work by showcasing services, credentials, and area coverage so homeowners find trusted help fast.